Good afternoon, everyone. Thanks for joining us at Propulsion and Energy here in the Hub. I would like to welcome this afternoon Mr. Conner Prochaska, who is the Chief Commercialization Officer for the Department of Energy Office of Technology Transfer. Today, we're going to be talking about how the DOE powers the journey to Mars and beyond. Conner will give his presentation. You can use your chat feature to ask questions, and then we'll open for totally open Q&A at the end of your presentation. Conner, over to you.
Well, great. I thank you very much for the opportunity to talk a little bit more about what the Department of Energy has done. As Vicki noted, my name is Conner Prochaska, and I am the Chief Commercialization Officer for the Department of Energy and the Director of the Office of Technology Transitions. In that role, what we do, and we'll talk a little bit about it, but we really want to make sure that we maximize the roughly $18 billion worth of investment that the Department of Energy puts forth every year in physical sciences across the spectrum. We'll talk a little bit about names and some of the misconceptions about the Department of Energy being named the Department of Energy, but hopefully we can talk a little bit today about some things you didn't know about, some areas of work that the Department of Energy has been involved in for decades that you may not have been aware of or not have been aware of the extent with which we are involved, and some areas that we're moving towards as we go forward in this new era of particularly space exploration and as we go to Moon and then on to Mars. I love showing this picture. This is the James Forrestal building. This is the headquarters of the U.S. Department of Energy. Across the street is a very, very beautiful building, which is the Smithsonian Castle, one of the prettiest buildings in D.C. And the joke is that from our windows looking at the Smithsonian, we've got some of the best views in D.C. And from the Smithsonian windows looking back at us at the Department of Energy, they have some of the worst views in D.C. because it's not a traditionally appealing building. But I hear that it's a big, brutalistic centerpiece and a piece of architecture of note for that aspect of it. But nonetheless, it's always fun to share this picture and to talk a little bit about what we do at the department and the Office of Technology Transitions, because you literally can't find the front door when you look at this picture. And so what we try to do at the Office of Technology Transitions is to be your conduit into how to partner with the Department of Energy, how to access our research, our researchers, and our amazing facilities that we have spread across the country at our 17 national labs and 5 production facilities. So if you hear nothing else, be aware that the Office of Technology Transitions is here to help connect you. We are not your final stopping point at any point in the Department of Energy. We are simply the conduit to introduce you to the offices, the programs, and the labs, and the researchers that could help you accomplish your task and hopefully build partnerships that help those researchers accomplish their tasks that they work on in the basic science and applied sciences across the department. This is our footprint. You heard me mention in the last slide that we've got the 17 national labs spread across the country. This is a great visualization of how spread across the country they really are, from the San Francisco Bay Area of Berkeley National Lab and SLAC, all the way to Oak Ridge, Tennessee, and Savannah River in Georgia, up to Brookhaven National Lab up in Long Island. We are spread across the country. It's a pretty big footprint for a number of reasons. And for those that don't always know, the Department of Energy was born out of the Atomic Energy Commission, and our forefathers were the Manhattan Project footprint. And so that's where a lot of these names that you hear about all the time: Los Alamos, Sandia, Lawrence Livermore, Oak Ridge National Laboratory, and Y-12, some historic names in the atomic and nuclear energy world, which is kind of how we ended up in the beginning of space travel, being associated with and working with space industry and working with our counterparts over at NASA. And as we all know that the commercial space industry is growing, so is that footprint, and we want to make sure that we're also at the forefront of that. You know, some great stories that people often don't understand is that we've been involved over 30 different missions for 50 plus years with NASA and with space, starting with the Curiosity rover currently on Mars, to Galileo and its mission to Jupiter, the Cassini mission to Saturn, and then Voyager and New Horizons, which are still trucking along, exploring the outer bands of our solar system. It's pretty exciting to be involved in all of that, but we want to make sure that the department continues to be involved and that people are very aware of what we do. The scientists at DOE's Berkeley Lab, as an example, the scientist Luis Alvarez, he proved that an asteroid the size of San Francisco crashed into Earth some 65 million years ago, leading to the demise of the dinosaurs. Another scientist at Berkeley Lab, Saul Perlmutter, was actually awarded the 2011 Nobel Prize for Physics for the discovery of dark energy and the accelerating expansion of the universe, and his theories on that. Since then, DOE's continued to build not just on that, but on a number of different areas, including just this past January, the Dark Energy Survey, an international collaboration hosted by DOE's Fermi National Accelerator Laboratory, which is just outside of Chicago, a 6-year survey of more than 300 million distant galaxies. The 50 terabytes of data collected are now being analyzed to provide more insight into the nature of dark energy. So those are some areas that, once again, people don't traditionally think about the Department of Energy being involved in with our supercomputers and with our massive capabilities and facilities. But we're at the very forefront of everything from the history of space and to where we go next. One area in particular is our RTG missions, which are radiothermal isotope thermal generators, excuse me. The RTGs are what power those rovers and those satellites and exploratory missions. And this is a great slide to really bring into awareness how those radioisotope thermal generators actually are created. We use multiple national labs, and then they go from Los Alamos to Oak Ridge to Sandia, and then end up finally at Kennedy Space Center there when they're ready to go. And it's just a good visual to see the extent with which we are already working with a number of different players in the space industry, in particular NASA for this. So really, everything we do at the Department of Energy when it comes to space can really be broken down into 3 buckets: persistent power, determined energy, and sustained innovation, as you see there. Our RTGs provide a reliable source of power for missions that demand more or that can't rely on solar to run all of their operations. Our staff and talent, which we talk about all the time, and you heard me mention it a little bit, but it's not just when we talk about technology transitions at the Department of Energy and commercialization efforts at the Department of Energy, it's not just the research or the technology or the IT that we want to make sure people have available to them and have access to. We also want to make sure that they have access to our amazing talent that's spread across the country, some of the brightest minds in any of these particular fields. It really is an amazing group of people that we want to make sure the U.S. taxpayer can get its maximum bang for its buck out of it. So our staff has decades of experience to produce products and that have been reliable, versatile, and they're proven. And then sustained innovation. We're constantly pushing the envelope at the Department of Energy for what's possible, engaging private sector partners to envision new commercial outcomes for what these technologies can do, and keeping America at the forefront of the global race for tech dominance, particularly as we go into this new challenge of making sure that we are in the driver's seat, for lack of a better term, when it comes to space exploration and commercial space as we go forward. So the Department of, well, I'll go back real quick because I do want to make sure that we talk a little bit, well, I'll move over here to the Department of Exploration. So one of the things that we talk about all the time is the Department of Energy is wildly misnamed, and you can say that in a lot of different ways, but it really is more the Department of Nuclear Weapons Security and Science, and the Department of Science. But one of the ones that's been talked about a lot as we embark on this new adventure into the space industry and working more closely with our space counterparts in the interagency and across the nation is we talk a lot about the Department of Exploration, the DOE as the Department of Exploration. So what does that mean, and what are we talking about? We talked about RTGs, but there's a number of different ways that we can interact and that we do interact. DOE powered the first man-made objects to leave our solar system, as we just talked about. But right now, as we talk about something as huge as understanding and the department's role in determining that a giant asteroid killed the dinosaurs, we are going all the way to the smallest level, which is a neutrino, and working on neutrinos at our Fermi lab outside of Chicago to shoot them into a mine shaft that's a mile underground in South Dakota to help unlock what happened after the Big Bang. So we're all the way across the spectrum. There's really not many areas or times when somebody says, hey, is the Department of Energy working on this? And there's not some way that we're not, at least in the periphery, working on it, which is very exciting. It's tough with all the cool stuff that NASA does to say that we go toe to toe with them, but we kind of think we do because we have such a breadth of areas of work. But we are very lucky to have a very extended and long partnership with NASA, and we hope to expand that, as we keep saying, into the efforts of LEO and low Earth orbit and other activities as we work to build a prominent space commercialization sector and space sector in the U.S. economy. And how are we doing that? Well, we are doing it in a number of ways. Under the very effective and efficient leadership of Secretary Bruyette, we have more or less dove into the deep end and head first into the space industry. We are building satellites. We have testing and evaluation capabilities that investigate for future opportunities like space-based manufacturing. When we talk about 3D manufacturing, once again, the Department of Energy worked and created at Oak Ridge National Laboratory broad area manufacturing for large-scale manufacturing, actually 3D printing a Shelby Cobra, which is just cool. And then all the way down to the smallest type of 3D manufacturing. And at Brookhaven National Lab in their nano labs, they have a little bitty statue of the Statue of Liberty that you can't see with the naked eye, but underneath the microscope you can see it. And the researchers are very quick to tell you that they could have made it smaller, but then you couldn't even see it with the microscope. But the technology is all the way across, and the ability to morph that technology or to adapt that technology to space activity is really exciting. We've joined the White House Space Council that's chaired by the Vice President. The Department of Energy was added to that less than a year ago, but we are very much a part of it and a part of that level of discussion of what we're going to do in the future when it comes to the space industry and the U.S. government. We're working closely with NASA right now to support the Artemis program and to align our programs to support a permanent human presence on our closest neighbor, which is the moon, which is the first step to the next step, which is Mars. The Secretary also has directed the Energy Advisory Board, or the SEAB, the Secretary's Energy Advisory Board, to develop strategic advice and guidance on our space-related programs. One of the things that we talk about at the department, and is difficult with such a large department with, as I mentioned, $18 billion of just research. That's not, I mean, the budget is twice as big as the department, and spread across, is us trying to make sure, us being leadership of the department, making sure we're aware of everything we're doing. And so anything we can do, one step is that we've created the Space Coordinating Group within the Department of Energy that does just that, looks at all the disparate efforts that are out there and tries to bring them together so that we, as leadership of the department, are aware of all the different activities that we are undertaking that are related to space activities. One of the ways the Secretary has done that as well is he has asked Admiral Richard Meese and Norm Augustine, two tech titans in the industry, to look at how we can have the best and most coherent and effective strategy going forward when it comes to space travel and space commercialization. And we at OTT are directly engaged with the Space Office at the Department of Commerce in efforts just like this one right here to make sure that we continue to, as I said earlier, be that conduit, be the area that you can come ping us, and we can help find you the best place to have the most effective interaction with the department. Some ways that we do what we do, and also technology transitions, not just in space, but across all the different technologies that the Department of Energy tackles, is we really break it down into three buckets: promotion, access, and policy. When we talk about promotion, this is as simple as getting less people to say, I didn't know the Department of Energy did that. And one of the ways we do that is through what we call our Innovation X Lab series. These are quarterly series, and you can see down at the bottom of the slide some of the topics that we've tackled. Similar to space, these are topics and technology areas that we have identified as areas where research is going on across the Department of Energy complex. And we want to be able to bring them together and really engage industry. The department does a great job and often has researchers talking to researchers. What we want to do better at is making sure that our researchers and where we are with the research is being well known to private industry, and there's an interaction there. And it's not just private industry. If you look at grid modernization, which we did in January 2019, a big step in that was bringing state regulators, private industry, and private companies, our researchers, all together to sit in one room and really identify all the way up and down the chain where the issues were and where the problems were and where we could do a better job at integrating to modernize our grid at the department in the United States. One of the ways, as you heard me say, promotion, access, and policy, our lab partnering service falls directly into our access efforts. It's labpartnering.org. The website's at the bottom there. It's labpartnering.org. And one of the great things about this website is it's a one-stop shop, or as close as we can get to a one-stop shop. It's got over 40,000 patents available for licensing. It has technology summaries. It has, once again, access directly to our scientists and researchers that you can ask them questions. And then it also has our user facilities. And when I talk about our user facilities, I want to make sure people understand what I'm talking about. The Department of Energy has a number of facilities around the country that are available for use for private use. And these range from our supercomputers. We have 4 of the 10 fastest computers in the world belong to the Department of Energy. 3 new exascale computers on the way, which will all be the fastest computer in the world once they start. All the way to our light sources. A light source at Brookhaven National Lab, to our accelerators across the nation, our user facility and kind of maker spaces that we have, such as our 3D printing, broad area manufacturing 3D printing capability at the Advanced Manufacturing Facility down in Oak Ridge National Laboratory, and everything in between. So these are areas and opportunities to really make sure that you can take full advantage of some of these great facilities and areas of expertise that we have. And then that last one, I always want to make sure that we talk a little bit about as we are in the COVID era. We have curated a landing page on labpartnering.org that is technology and items that we believe are pertinent to the COVID discussion. That goes everything from advanced manufacturing capabilities for PPE, to what we did at the very beginning of COVID with our supercomputers and running proteins to give doctors and researchers a leg up and a head start on looking for a vaccine, and everything in between. So I always want to make sure that it's not always obvious, some of this technology and what is available and how it directly interacts with the COVID fight, but a lot of people have gone on there and looked at it and realized that some of this is some very interesting technology. For instance, Sandia National Laboratory able to retrofit machines that weren't purposed for respirators that can now be used as respirators to some of their technology. So we want to make sure that those are available as we continue in the fight against COVID. Solutions Exchange is another access program. What this is a lot of times when we talk to people, and they say, well, do you have a leave behind? Can you tell us, just a quick summary of the capabilities or what the activities are at the Department of Energy? The short answer is no, because it probably wouldn't fit in the back of a U-Haul truck if we had that. So what we have found that works is when people tell us what their actual problem is, then we can more likely and more easily identify where, how, and what they should be introduced to and who they should be talking to. And that's what Solutions Exchange is. Through labpartnering.org, you can put a problem in, it's a process so that we can marry you up with the correct office or lab or researcher to hopefully solve your issue. And this is our contact information. Please don't hesitate to reach out. That's what we're here for. We are here to make sure that you can find a home, and hopefully you heard some things during this little chat today that you said, wow, I didn't know the Department of Energy did that. So if we've done that, then we've worked partially on our job. The next job is to make sure that we can build any kind of relationships. And we have found historically with the department, the sustained relationships are the ones that bring the most fruit. And we want to make sure that there's an avenue to make sure that our relationships are more purposeful, less accidental, and more sustainable as we go forward. So with that, I really appreciate AIAA giving me the time here today, and appreciate everybody taking the time to chat. So thank you very much. And I think I'll hand it back over to Vicki.
Thank you, Conner. I really enjoyed today's presentation, and especially the new illustrations to help us understand where the labs are located and how they're actually involved in some of this great work that's taking place. AIAA is working with the DOE OTT to help them expand their messaging. And so the things that Conner was talking of in terms of promotion, access, and policy are all very important to us and what we do with the aerospace industry. Upcoming, I believe it's September or October, Conner's going to be a guest of ours on our Space Policy podcast, so we'll be looking forward to that. And in the meantime, I would like to ask one question of you, and then we can open things up to other participants. So, of course, we saw lots of activity around the Mars rover and the Mars mission out of the DOE. What would you say is the most active lab right now, and what's the reason behind that? Is it because of something they're doing with COVID or with the Mars rover? And what's going on there?
Yeah, so when we talk about space in particular, Idaho National Lab takes the cake. I can't, we love all of our children the same. So, but I think everybody recognizes them as the leaders when it comes to particularly RTGs. And the reason for that is they are our civilian nuclear labs. So our labs, they all have multiple capabilities, and they have multiple areas of effort that they work on. But some have more centered and are more applied. So INL is our civilian nuclear lab. It's just under 1,000 square feet, or excuse me, 1,000 square miles in size up in Idaho, because you want that if you're going to work on civilian nuclear testing capability. Whereas our 3 weapons labs that work mostly on our weapons, which is Los Alamos, Sandia, and Lawrence Livermore. National Renewable Energy Lab, it's pretty self-explanatory what that one works on, is renewables. Oak Ridge National Laboratory does a lot of our advanced manufacturing. So they all kind of have a little bit of a niche and a little bit of an area that they focus on in particular. It just so happens that Idaho National Laboratory is a very large nuclear lab and has had a long time relationship with NASA.
Great. I just wanted to ask if there's anyone in the audience that would like to ask a question. You can unmute yourself. Well, I'll go again, Conner, if you don't mind. A lot of the attendees at Propulsion and Energy are young professionals, sometimes students, and oftentimes they're looking for sort of their next point of entry within an organization. What kinds of people do you look for at the Department of Energy Office of Technology Transition?
Well, so in OTT, we have a wide variety, everything from a newly created market analysis team that we have at the department, or at OTT in particular, to help us educate ourselves and our colleagues across the department on the research roadmap once things go, so that they can work their way towards commercialization. So everything from somebody in that world, right, with a business degree and a business background is perfect for that. All the way to commercialization executives that we have on board. And what that program is this idea that you have a unique skill set and you have an idea or a problem in the energy technology commercialization effort, right? That is a broad brush, but niche problems such as if we don't believe that there's the correct type, and this kind of goes to that policy bucket that I mentioned. If you don't believe that there's the correct type of contract or agreement in existence that allows companies to take technology and run with it, or keeps them from working with the department, that would be an example of a very niche thing that we'd want to focus on, laser focused, look at it, see what we could tackle. And then of course, program managers, which is a wide skill set, and I think people can recognize what that means to manage a program. We do a number of direct programs, such as our Energy I-Corps program, where we teach and provide training to researchers at our national labs to help them become more entrepreneurial. And so that's right there. That's a classic. How do we manage the program, making sure that the funding gets there, making sure that the applications are worked through the building. And so it's a broad area. There's, and then there's myself. I'm a lawyer by trade, and which helps discussing a lot of the IP issues and things like that. So it's pretty broad across the spectrum.
That's great. It's interesting. Many of our corporate members across AIAA are saying the exact same thing that you did when you first started responding about having business skills. So you may need to be an engineer, but you also need to have some analyst skills and a strong business acumen as well.
Well, and one of the things that's interesting about it is the Department of Energy traditionally just does not have that thought process. For a long time, a lot of what we did was frankly a secret. And when it comes to building nuclear weapons and protecting that stuff still remains part of our DNA and what we do. But we want to make sure that we're much more actively engaging, that we can keep the brightest minds in the United States engaged and with us, and give them the opportunity to not just do that, but then be entrepreneurs as well. And one of the things we see a lot is it's not that people weren't thinking or didn't want to go help get their technology out the door. It's just not one of the questions on the discussion. And as soon as we ask, and one of the things I say all the time to researchers that are thinking about being entrepreneurial, you don't need to know exactly where the technology is going to go right now, and it doesn't have to be right. You should just take a guess, and that can evolve as the technology and as the market and as the world changes. But you should always be thinking about it and putting some type of effort into thinking about how can this really go out and make an impact, because it's very easy to put the blinders on and get your head down on the bench, in the scientific bench, and not think about where it could actually go beyond just publishing a paper, which is fine too, by the way. We love our published papers, and we want to see that. It's our mission at the Department of Energy to attack basic science. But we want to make sure we're thinking about the next step too.
Absolutely. Well, thank you for that. We do have a question from the audience. Elaine Petro would like to ask.
Hi, can you guys hear me?
Yes.
Hi, Conner. Thank you for your presentation. I'm a new faculty member at Cornell University, and I work in electric propulsion, so electrically powered spacecraft propulsion. And I'm interested at the intersection. The energy source is really important, as you can imagine, to that. I'm sure you know. So anyway, all that is to say, I'm curious if you can speak to Department of Energy visiting faculty opportunities, if those exist, and sort of like opportunities for faculty to maybe spend some time at DOE Lab.
Yeah, so at our national, thanks, Len, appreciate it. The short answer is yes, those types of opportunities exist. I'm happy to, we'll make contact and go through the different types of opportunities. But what I do want to make sure is that people know, yes, things like that exist. Secondly, the reason it's just not a blanket program that I can respond immediately to, here's the one-stop shop, is of our 17 national labs, they are contractor run, government owned. So there is a overall M&O contractor that runs the national labs. And so they tend to have different programs that they use. Perfect example, University of Chicago is the contractor that runs Fermilab and Argonne National Laboratory outside of Chicago. So they've got unique programs up there versus the Pell and the University of Tennessee that run Oak Ridge National Laboratory, or Honeywell, which runs a different lab. So so everyone's got kind of unique situations, but the short answer is yes.
Thanks, appreciate it.
Any other questions from the audience? Well, Conner, thank you. We're right at our 30-minute mark. Great job, and we look forward to continuing to work with the DoE OTT.
Outstanding. Thank you very much for the time. And I just want to remind everybody to please drop us a line at ott@hq.doe.gov if there's any questions you have or any ways that you would like to engage with the department. So thank you all.
Sounds great. Thank you.